This is Jeremy Clark of JeremyBytes.com, and today we're going to continue our series on task and await in C#. This time we'll see the flexibility that we get when we're using the task object by looking at some of its properties, including IsFaulted, IsCompleted, and Task.Status. As a reminder, we are working with the task asynchronous pattern, which is task-based, and a task represents a concurrent operation. Now, we do get quite a bit of flexibility when we're using task. We can chain them together or combine them in different ways. Today, we'll look at the code we created in a previous example, and instead of using separate continuations, we'll combine them into a single continuation and add some conditionals. Now, what we'll find is things are not always what they seem, so we're going to be on the lookout for a big gotcha this time around. So let's head over to our code and see what we have right now. So here we are in Visual Studio, and let's just run our application to remind us of the functionality. So if I click on Fetch Data with Task, we'll see that our button's disabled, our UI stays responsive, and then once our asynchronous process completes, our list box populates. And the way we're doing this right now is with 3 separate continuations. So let's just do a quick review of what happens when we click on our Fetch with Task button. So the first thing we do is we disable our button so that we can't click it again. Then we clear our list box. And then we make our asynchronous method call. In this case, it's repository.get. And as a reminder, this returns us a task of list of person. Then we create 3 separate continuations to decide what happens once that task completes. Our first continuation is marked with only on ran to completion. So this is our success state. And if things complete successfully, we'll go ahead and populate our list box. Our second continuation is marked only on faulted. So this will only run if our task goes into a faulted state, and that happens if it throws an exception. And then in the body of this method, we just loop through the exceptions and display them in message boxes to the user. For our final continuation, we want this to run every single time, whether we're successful or whether we get an exception. The body of this method re-enables our button so that we can click on it again. But this is quite a bit of code, and it's starting to get a little complicated. And since I really don't need all of the features that this is providing to me right now, what I'd like to do is combine all of this functionality together into a single continuation. So let's go ahead and just do that, and then we'll explore our different options. So the first thing we'll do is we'll take our error handling code. I'll go ahead and cut that and put that at the top of our first continuation. And then I'll take our last piece of code from our third continuation, which re-enables our button, and we'll go ahead and just put this at the end of this block. Now, since I want this code to always run, I can get rid of this only on ran to completion parameter, and along with that, the cancellation token that we weren't using before. And we'll go ahead and delete our empty continuations as well. Now, I don't necessarily expect this code to run as is, but let's go ahead and just run it to see what happens. So I'll click on the Fetch Data with Task button. We'll wait our 3 seconds. And then we see that we get an exception. And notice the message, object reference not set to an instance of an object. That's because we're trying to access the exception property of our task, but since our task didn't throw any exceptions, this is actually null. Well, it turns out that task has some properties that we can use to conditionally run this code. So what we'll do is we'll say if t.is, and notice these properties on our task. We have isCanceled, isCompleted, and isFaulted. So I can easily add a conditional here for isFaulted, and then this block of code will only run if our task is in the faulted state, meaning that it does have an exception, so our exception property should be populated. And if we run our application again, we'll see that this time when we click our button and wait our 3 seconds, that our method does complete successfully. Okay, so that's pretty easy so far. Let's go ahead and test our other state. What happens if we get an exception? So I'm going to go back to my asynchronous get method and uncomment the piece of code that throws an exception. And let's go ahead and just rerun. This time, I'll click the button, we'll wait our 3 seconds, and then we do get the pop-up message that we expect, which says get operation is not implemented. So let's go ahead and click OK to clear this message, and we'll see that we do have an exception. Now this should look familiar. This is exactly the same exception that we saw when we were looking at basic exception handling. And the error message is 1 or more errors occurred. And this is because we're trying to access the result property of our task. Now, since our task is currently in a faulted state, result is invalid, and that's why we're getting the exception here. But we did see some other conditionals that looked pretty useful, so let's go ahead and try one of those. So around the block of code where we're accessing the result, I'll just say if t dot is completed. That sounds exactly like what I want here. So if our task is faulted, we'll go ahead and show the exceptions. And if our task is completed, we'll go ahead and populate the list box. And either way, we will re-enable our button when we're done. But as we'll see, things don't always go according to plan. So if I click the Fetch Data with Task button, we'll see that we do get our exception message. And if I click OK, well, I get that same exception that we just saw. Now, I don't expect to be inside this block of code. I expect to only be here if I completed successfully. But that's when we need to look a little bit closer at what this IsCompleted actually means. So I'll go ahead and hit F1 to get into help. And the important part is in the remarks. IsCompleted will return true when the task is in one of three final states: ran to completion, faulted, or canceled. So what we see here is that IsCompleted does not mean completed successfully. What it means is the task is no longer running. But fortunately for us, there is another property on the task that we can check. So instead of looking at IsCompleted, let's look at the Task.Status. Now I'm just going to hit F1 here so we can take a look at what Task.Status is. And what we see is this is of type Task.Status, which happens to be an enum. And we can see there are quite a few values that we can look at here. Now we can look at this to see whether it's running or not, and even if it's still waiting to be activated. But the states that we'll pay close attention to are canceled, faulted, and ran to completion. Now we'll be looking at cancellation in our next episode. So for now, we'll just look at faulted and ran to completion. Notice the description of ran to completion. The task completed execution successfully. So that means it is not in a faulted state and it is not in a canceled state. So this is really what we want to use in our code. So what we can do is we can say if Task.Status equals Task.Status.ran to completion, then we want to go ahead and populate our list box. And now if we run our application, we'll see that when we click the button, we will get the exception message that we're expecting. And when we clear that, our button will re-enable. So we did complete successfully in this case. And if we go back to our asynchronous method and get rid of the exception message, then when we rerun our application, we'll see when we click the button that our list box does populate as we expect it to. Now, I'm not a very big fan of this code in its current state, and that's because we're mixing and matching different things here. So I have an if statement that says task.isFaulted, and I have a separate if statement that's checking the task status. And the same thing is true once we start looking at cancellation. We'll probably want something that says, if the task is canceled, then we'll go ahead and handle the canceled state. But I'd prefer my conditionals to look pretty similar to each other. So instead of saying t.isFaulted, I'd much rather use t.status equals Task.Status.faulted. And the same is true for cancellation. So instead of saying is canceled, we'll check the status, and we'll go ahead and compare that to the canceled state. Now, these really are exclusive states, so instead of just being if statements, they really should be else if statements, so that only one of these three will run in any particular instance. And to me, that sounds like a great place to use a switch statement. Now, if you're using ReSharper or another refactoring tool, it's really good at doing all of this work for you. But we'll do things a little more manually, and I'll be using the code snippets that are built into Visual Studio. So I want to use the switch statement. So I'll just type in switch and then hit tab twice. And this is where code snippets get really cool. If I say t.status and hit enter, the code snippet recognizes that this is an enumeration. So it actually fills in all of the cases that we can have here. Now, I actually don't need to worry about most of these because remember, we are in a continuation. So this will only run after our task is done running. So these ones that pertain to waiting to run, waiting to be activated, and running, we don't need to worry about those. So we'll go ahead and just keep canceled, faulted, and ran to completion. And let's just move our code up there. So we'll take our note that we have for a cancellation in the future. And then we'll take our exception block. And then we'll take our completion block. And to line things up, I'm going to use the keyboard shortcut Control-K, Control-D, and that will indent things so that they're in line with each other. And now I can get rid of these empty if statements. So let's take a look at our method now. So the top of our method is the same. We're disabling our button and then clearing our list box. And then we're calling repository.get to get our task of list a person back. But now we have a single continuation, and this will run regardless of the state of the task after it's completed. And then to decide which code we want to run, we just look at the status property of our task. If it's canceled, we'll do one thing, and again, we'll look at cancellation in our next episode. If it's faulted, we'll go ahead and show the exceptions to our users. And if we ran to completion, we'll populate our list box. And then outside of our switch statement, we do re-enable our button. So regardless of the task status, we do re-enable that button every time. And let's go ahead and run our code just to make sure this still works the same way it did before. So if I click on the button, we'll wait our 3 seconds. And then we see our list box populates and our button re-enables. Let's go ahead and put our exception back into our asynchronous method. And then we'll run our code again. So we click the button, our button disables. Then we get our exception message back. And once we say OK, our button re-enables just like we expect. So what we can see from this code is we have a lot of flexibility when it comes to dealing with tasks. So instead of having separate continuations, we can check the status of the task and use that to determine what code we want to run. So if we really do need to chain our tasks together, we can do that. But if we just need a simple continuation, we can use a switch statement and make our code much simpler to follow. So we do get a lot of flexibility with task, but we need to be aware of how the properties work because it's not always obvious. First, we saw IsCanceled, IsCompleted, and IsFaulted, and these looked really promising. But then we found out a bit of a gotcha. IsCompleted does not mean what we think it means. Even though our intuition tells us that it means completed successfully, all it means is that the task is no longer running. But fortunately, we have another property we can check, which is the Task.Status. This is an enum, and there are a lot of different values that we can use. Some of these we can use to see whether our task is currently running, or even if it's been created but hasn't kicked off yet. But the values we care about today are canceled, faulted, and ran to completion. This will tell us whether our task has been canceled or if it's in a faulted state. But more importantly, the ran to completion tells us that our task did complete successfully, and it is not canceled, and it is not faulted. So that's a really quick run through some of the properties that I find useful on task. And again, we have to watch out for that IsCompleted property. It doesn't mean what we think it means. Next time, we'll take a look at cancellation, and we'll see how to cancel using both await and task. And one thing we'll find is using a cancellation token is not as straightforward as it seems. It's definitely not difficult, but it can trip you up if you don't know what you're looking for. So until then, be sure to visit www.JeremyBytes.com for more information, and we'll look forward to seeing you next time.